Hello, today we're going to talk about solving systems of equation by using substitution. Yesterday you learned how to solve systems of equations by graphing. Remember that graphing, when you solve a system of equations by graphing, the solution is the point of intersection. So now we're going to find the point of intersection without graphing. And there's two ways of doing that. And one of them is using substitution, and the other one's using elimination, which we'll talk about tomorrow. So far we've done graphing for solving systems of equations, and now we're going to add substitution to our toolbox of how to solve them. So looking at this, we want to know what is the solution to this system. So we want to know what values of x and what value of y, when we plug it in, will work for both of these. Now you could use guess and check by trying to take two numbers and adding them to get negative 32, and then taking the x value times 3 and see if you can get y. Or if you know how to substitute, you can do that also. Now substitution works great when you have a variable equal to its something. So you have x equal something or y equals something. The reason that substitution works better than graphing is graphing you have to be exact. Not many of us carry around graphing paper with us everywhere we go. And if the answer is a fraction, you can't get the exact answer by using the graphing method. So substitution will always give you an exact answer. So if I look here, I see that y equals 3x and x plus y equals negative 32. If you look at this literally, it's like saying y equals 3 times 2. And if I have x plus y equals negative 32, I can take this 3 times 2, whatever that equals, and plug it in for y. And that's what we're going to be doing. We know that y equals 3x. So I'm going to take that and substitute it in to y for the second equation. So I'm going to rewrite the second equation, x plus, and instead of y, I'm going to put in 3x equals negative 32. Now looking at this, I can solve this just by combining like terms, and x plus 3x equals 4x. Shh, I'm trying to teach you how to be quiet. Sorry, that's Claire. Hold on a second. Okay, so now we know that x plus 3x equals 4x, and that equals negative 32. Now, I can solve for x by dividing both sides by 4. Now we can solve this by dividing both sides by 4. Those cancel. And I get x equals negative 32/4, which is negative 8. Now, remember I need a point, so I also need to know what y is. Now I can plug in negative 8 for x, and I get y equals 3 times negative 8, y equals negative 24. So I have negative 8 and negative 24. The next one, it says, what is the solution to the system? Now, looking at this, I see that they both equal y. Well, if they both equal y, then I know that they are both equal to each other. So I can take 2x plus 7 and set it equal to x minus 1. Or in essence, you're taking 2x plus 7 and plugging it in for y. So all I did is rewrote it. I knew that y equaled 2x plus 7 and y equals negative x minus 1. Since they both equal y, I set them equal to each other and solve for x. So subtract x from both sides. You get x plus 7 equals negative 1, minus 7 from both sides, and you get x equals negative 8. Now you have a choice. You can plug that into the first equation or the second. I'm going to plug it into the second, and I get y equals negative 9. Now, looking at this solution, this puts us into a bit of a pickle because we don't have any that say x equals something or y equals something. So we have to make it work. So I look at my variables. So I have 3y, I have positive 4x, I have negative 2xy, and I have positive y. Only one of them has a 1 as a coefficient, and that is the y. So that's what I'm going to solve for. So I'm going to rewrite the second equation. I'm going to solve it for y. So I'm going to add 2x to both sides. This gives me y equals negative 3 plus 2x. Okay, that gave me what my y equals. Now, I need to plug that in for y, but I want to remember to do it to the other equation, not the one I changed, because I would end up with infinite solutions. So I'm going to plug this in for y in this equation. So I now have, instead of 3 times y, I'm replacing y with negative 3 plus 2x. And then I'm going to add 4x equals 14. And then go ahead and solve that. Distribute, you get negative 9 plus 6x plus 4x equals 14. Combine like terms, you get 10x. Add 9 to both sides. You get 10x equals 23. Divide by 10, and you get x equals 2.3. Now plug that in for x for any of the equations. And I think I will plug it in for the second one. So I'm going to have negative 2 times 2.3 plus y equals negative 3. That gives me negative 4.6 plus y equals negative 3. Add 4.6 to both sides. That gives me y equals, make that a 0, 1.6. So then my answer is x equals 2.3 and y equals 1.6. Now imagine if you tried to graph that, there would be no way you could come up with that perfect answer. Again, looking at this one, look for the variable that has a 1 in the denominator. That would be here, 1x. So I'm going to solve that. I'm going to subtract 3y from both sides. And I get x equals negative 3y minus 7, or minus 7 minus 3y. Now I'm going to take that, and I'm going to plug it in for x in the equation that I didn't mess with. So now I have 6y plus 5 times negative 3y minus 7 equals 8. Now you should pause the video here and try and solve it, and then play it and see if you get the same answer I do. So I'm going to distribute. I get 6y minus 15y minus 35 equals 8. This gives me negative 9y minus 35 equals 8. Add 35 to both sides. Negative 9y equals 43. Then divide both sides by negative 9. And you get y equals negative 43/9. And you can leave it as an improper fraction. Then you want to plug that into one of the equations. I'd probably plug it into the second one. And you get x plus 3 times negative 43/9 equals negative 7. Those cancel. I get x equals negative 7 plus 43 thirds. This is 21 thirds. So x equals negative 22 thirds. Now we can take a word problem, and if we write two equations for it, we can solve it. So it says a snack bar sells two sizes of snack packs. A large snack pack is $5 and a small is $3. That should be a capital I. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? So if I look, I know that the total number of snack bars was 60. So that means the small plus the large equals 60. You look for your totals for these, okay? The second total they give you is $220. Well, how did we get $220? Well, we sold smalls and larges. Well, how much were they? The small was $3, and we got $5 for every large. So the hardest part in these is writing the equations, and the key to remember is that you want to find the totals. There should be two of them. One always has to do with money, and one has to do with just the variables. Now I have my two equations. I want you to pause the video, solve for S and L, and then come back and see if you got the right answer. So I'm going to solve this for S. It doesn't matter which one you solve it for. And then I'm going to plug it in for S over here. So 3 times 60 minus L plus 5L equals 220. Distribute 180 minus 3L plus 5L equals 220. Subtract 180. You get 40. And 3L plus 5L is 2L. Divide by 2. That gives you L equals 20. So that means you sold 20 large packs. So if I sold 20 large packs and I had 60 on all together, I sold 40 small ones. So my answer would be, how many small snacks packs did the snack bar sell? 40 small. That's what they wanted to know.